Hello friends, today's question. In figure, a block of mass m is placed on a table with rough surface having coefficient of friction mu1. Another block of same mass is placed on the vertical rough surface of this block with coefficient mu2, where mu2 may be greater than 1. If system is released from rest, find the maximum mass of block A so that the block of mass m does not slip. So this is A block. It is connected with a bigger block whose mass is also m, and small mass m is on the vertical face, and we have to find out the mass of this block A such that this block which is on the vertical face does not slip. So first of all, let's draw the free body diagram for the blocks. Okay, and for block A, this is block A, and let's call its mass as MA. So in the downward direction it is going to have MAG, and upward direction there will be tension T, and we assume that it is moving in downward direction with an acceleration of A. So we can write this equation as MAG minus T is equal to MA multiplied by A. From here we can write the equation for tension T is equal to MAG and minus MAA. Taking MA as common, we get tension T is equal to MA G minus A. Okay. So this is the equation for tension for block A. Now we assume that these two blocks are moving with the same acceleration A. Okay. Suppose, let us call this as block B and this as block C. Okay. Suppose block B and C move together with acceleration A. So now this will be B plus C, and the tension T, and the force of friction, let us call this FR1. So in the downward direction we are going to have MB plus MC multiplied by G, and in the upward direction let us suppose there is a normal N1. The value of MB and MC is same, so this will be coming as 2mg, and we can write the equation for friction FR1. You can say FR1 is equal to mu1 into N1, and our N1 will be equal to 2mg. So this will be mu1 2mg, and it is moving towards right side with the acceleration A, in this direction, the acceleration A. So we can write the equation as T minus FR1 is equal to MB plus MC multiplied by A. So let us call this as equation 1. So we already know the value of T from equation 1. FR1 is this one, so we substitute the value. So we write using equation 1, and let us call this equation 2, and equation 2 we get this as MA G minus A minus FR1 is 2 mu 1 mg is equal to MB and MC are same, so we get this as 2m multiplied by A. Now for it is said that block C should not be sliding. Okay, so we can say for block C not to be slipping on the vertical face of block B, the vertical face of block B, the friction should be static. Okay. The friction between the two should be static. So which basically means that FR2 should be less than equal to mu2 and the normal n. Okay. So let me draw the figure for block C. So this is our block C, and we have a friction force FR2. Okay, and there will be a normal acting in this direction, that is N, let us call that N2, and there will be a pseudo force in this direction, that will be MA, and in the downward direction we are going to have MCG. So this MA is our pseudo force. And sorry, this will be N2. Okay. And so from this figure we can say that N2 will be equal to MA, and FR2 should be equal to MCG, which basically is nothing but Mg. Okay. So now we are going to substitute the values for F2. FR2 is our Mg as well as FR2 is mu2 N2. Substituting value of N2, we get that FR2 substituting value of N2, we get FR2 is equal to, sorry, not equal to, less than equal to mu2 into ma. Okay. And fr2 is also equal to mg. Okay. So let us call this as equation 3. So from here we can say that using equation 3 we get mg is less than equal to mu m a. Here m cancels out the m, and we get this equation as g less than equal to mu to a. Let us call this as equation number 4. Okay. And we already have an equation. Okay, let me write it. But ma g minus a minus 2 mu 1 mg is equal to 2ma. So we are going to use this equation to find the value of a. So let's open the bracket. We get mag minus maa minus 2 mu 1 mg is equal to 2ma. So we are going to combine the like terms. Okay. So we get this as mag minus 2 mu 1 mg is equal to 2 ma plus ma. Taking a as common, so we can get the acceleration a will be equal to mag minus 2 mu 1 mg, and divided by, it will be 2m plus ma. Let this be question number 5. So using equation 4 and 5, using equation 4 and 5, we get, sorry, g less than equal to mu 2, substituting value of a, we get ma g minus 2 mu 1 g divided by 2m plus ma. Now we cross multiply it, and by cross multiplying we can say that 2m plus ma g less than equal to mu 2 ma minus 2 mu 1 m and g. Here g cancel out with g, so we get here as 2m plus ma less than equal to, we open this bracket also, we get this as ma mu 2 minus 2 mu 1 mu 2 m. Now combining the terms, we get this as ma minus ma mu 2 less than equal to, get this is minus, we can take 2 mu 1 mu 2 m minus 2m. So we can write this as ma mu2 minus 1 greater than or equal to, taking 2m as common, we get this as 1 plus mu1 mu2. So we get MA is greater than or equal to 2m1 plus mu1 mu2 divided by mu2 minus 1. And we are supposed to find out the minimum value of the mass MA. Okay. Therefore, the minimum value of, rather for mass of A is, rather will be MA equal to 2m1 plus mu1 mu2 divided by mu2 minus 1. Okay. Such that block C does not slip along the vertical face of block B, along the vertical face of block B. So this is the complete answer. Let me write it here. This is our block B. Okay, I think this must not be clear. Okay, this is block C, this is block A, and this is block B. So this completes the question. Thank you.